Everyone, today we're looking at today's daily Leetcode question, number 1701, average waiting time. It's a medium problem. Let's read the problem. So, there is a restaurant with a single chef. You are given an array of customers where customers I is equal to arrival I time I. And arrival I is the arrival time of the ith customer. The arrival times are sorted in non-decreasing order, and time I is the time needed to prepare the order of the ith customer. When a customer arrives, he gives the chef his order, and the chef starts preparing it once he is idle. The customer waits till the chef finishes preparing his order. The chef does not prepare food for more than one customer at a time. The chef prepares food for customers in the order they were given in the input. Return the average waiting time of all customers. Solutions within 10 to the power of negative fifth of the actual answer are considered accepted. So we have some examples. So the first customer arrives at time 1, and then the chef takes his order, starts preparing immediately, time 1, finishes time 3 because it takes time 2. So the waiting time of the first customer is 3 minus 1 is equal to 2. So then the second customer arrives at time 2. The chef takes his order, starts preparing it at time 3, finishes at time 8. So the waiting time of the second customer is 8 minus 2 is equal to 6. And the third customer arrives at time 4. The chef takes his order, starts preparing at time 8, finishes at time 11. So the waiting time of the third customer is 11 minus 4 is equal to 7. And then we're going to add together all these waiting times, divide by 3, and we get the average waiting time of 5. And I'm assuming the second input is pretty much the same idea. Okay. If we look at the constraints, customer's length is smaller than or equal to 10 to the power 5, meaning that the solution can run in, at worst, n log n time. And then the arrival time is below 1,000 or 10,000. And then, and the arrival times are sorted in increasing or non-decreasing order. Okay, so based on this problem, I think we can just simulate it. So we already have that the arrival times are already pre-sorted. So we simply have to keep track of when the chef finishes each customer's meal. So for example, what we would have to keep track of is we do chef starts at 1, right? We look at the first customer, we add 2, so the chef finishes the customer's meal at 3, so we have like a total. It's like the total waiting time, 0. So we do 3 minus 1 is equal to 2, and we add that to total. And then at 3, we add the next customer's time to prepare, which is 5. And then we do 3 plus 5 is equal to 8. And then we do 8 minus 2 is equal to 6. So then we add 6 to the total. And then we maintain that we keep that 6. Or sorry, we keep that 8, right? Because the chef is working at one meal at a time in the order that the customers are coming in at. So then we add a 3 to that 8, and we get 11. 11 minus 4 is equal to 7. And then we just sum everything up and divide by the total number of customers. Hold on. Let's see if there's any other. Okay, no. It's just for the order they were given the input. Okay, that should be pretty easy. We just do total is equal to 0. And let's have a... Okay, I'm going to name this variable time. It's going to represent when the chef is ready. So time is going to start at 1 because the chef starts at time 1. If you look at the examples, and we can simply just loop through all the orders. So let's see. I'm not sure if we're able to do this because it's technically not a tuple, but let's give it a try. So we do arrival. Oh shoot, this one's also called time. Okay, we're gonna name this one cur for current time. So we can do for arrival time in customers. I'm just gonna first make sure that the syntax works. Let's return something random. Okay, it does work. Good. So we can do cur plus equal time. So this is when the chef will finish preparing that customer's meal. And then we do total plus equal time minus arrival. So that's how long the customer has to wait. And then we can simply do return total divided by number of customers, which is the customer's length. Let's run this, see if this works. Uh-oh. Huh? What did I do wrong? Oh, okay, I subtracted the wrong thing. Oops. Should be cur minus arrival. And I still did it wrong. Okay, I guess the second example is actually important. Oh, right. Okay. I'm stupid. So the first thing that should happen is cur is equal to max cur and arrival, because the chef can't start preparing for a dish before the customer has arrived. Um, okay, wait. This should work. Yep, does look like it works. Let's submit it. Okay, and that's why you read all the examples. And it looks like I did really bad compared to the average. Let's see what the average person did. Okay, you know what? It looks about the same. I think at this variation, it's mostly just it's like random. Like it's just 50 milliseconds. You can just submit it again. Usually you get a better time. Oh, never mind. I guess my code is just extremely bad. It's probably the max function or something. Or the total divided by length of customers. Okay, but yeah, I think that should be how you solve this problem. Let's look at the editorial just to see if I missed anything. Their solution seems kind of complicated actually with the way they simulate. They have a lot of variables to keep track of everything. Maybe that's why they have 4 stars. But the basic idea seems to be the same. Oh, we have a Leetcode solution. He's done the exact same thing as me. Or pretty much. Let's see, cur is equal to max. Oh, he uses weight. Okay, weight for total. So weight plus equals cur minus t. I mean, yeah, it looks pretty much the exact same, except he uses his shorter syntax. But this should be a very valid solution, even though it was unfortunately only better than 16% of all solutions. But yeah, I'll see you guys tomorrow, and thanks for watching. Bye bye.